Hey there, Python programmers. In today's lesson, we're going to learn about a fun yet sometimes complicated topic called recursion. So, to first understand recursion, you have to understand recursion. And I'm hoping if you didn't get that joke now, you will by the end of the lecture. So, recursion is the process of a function being able to call itself and kind of break down a problem into smaller pieces until we solve what we're trying to solve. It is not always the best thing to use. So again, it's rather situational, but there are times when it is the best way to solve a problem. So we're going to start out with a simple example as we can, because we can use recursion to iterate through a list just like we would a for loop. And that hopefully will show us a little bit about how it is working so that we can go on and use it for a little more complicated topics. So I'm just going to make a quick list of a couple of foods, and then we'll write a recursive function to iterate through it. Throw in some chicken tenders, crowd favorite probably, and then maybe we'll do apple pie. Sounds delicious. Cool. So we have a list of foods and we want to iterate through it, but we're going to use recursive. Let's call this recursive iterator. And it's going to need to take in a list object for us, right? Cool, DJ. All right, so when you write a recursive function, there are two things that are really important to include. And if you forget to do either one of them, you're going to run into an issue where your code will keep running until you get an error, what would be called a stack overflow. So the first thing is a base case. What are we going to get to that will stop recursion? So how we're going to iterate it through this list is by slicing it. And ultimately, once we've sliced the list into having nothing left, we're going to want to stop. So that's what we can use. If the length of our list object equals 0, means we've sliced away all the values, that's when we will want to stop. And stopping basically means returning, ending the continual call of functions. Maybe for this, we want to print out each item as we're going through it. So we can print our list object, and we're going to print it at the key or index of 0. Then what we're going to need to do is the return from our function is actually going to call the function again. And I'm going to start out by making a big error just to show us what would happen. So we do need to invoke this. We're going to do recursive iterator. We will pass in our food. Again, I am planning to create an issue here. And here we see maximum recursion depth exceeded. And all we did is print out pizza very, very many times. So we did not include a recursive step here. We did nothing to make this list object progress to our base case of having 0 length. And that's why we did get this maximum recursion depth. And what happens is the function keeps calling the function again. And how recursion kind of ends is that when we get to this final base case, it returns that function. And then again, it keeps returning the different function calls until we have a value. So we need to change this slightly. And all we need to do is slice. So we'll start at 1, or the index of 1, because we've already printed out the index of 0 here. And I'm going to add one more thing. And this, again, is hopefully just going to show us what is happening. So we'll put a little note saying I ran, because again, we're going to see how many times this function gets called. And let's look at the list object each time. And I'm hoping the output for this will kind of show us what's happening here with our recursion. Oh, sorry, we got to do 1 till the end there. Bad. It's not, here we go. So we see the very first time when we print Iran, we have the whole list object, right? And then we come in and we print the first value. So we see our hamburger. And then what happens is we call recursive iterator again, but we've sliced our list, right? So we're calling it with, sorry, this goes higher. It starts with pizza. So the first time we print pizza, then we slice off that pizza and we run the function again with these values as our parameter argument. And then what happens is we print again, we'll print hamburger, and then we're going to call the function again with the remaining three values. So we see we printed pizza, then we printed hamburger, then we printed salad, and we see each time our list is getting smaller and smaller until we see we have I ran with an empty list. And when we get to that, what will happen is, hey, we finally have hit this condition where the length of the list equals 0. So we start returning, and this returns the very last function that was called. And then they kind of return all the way up to the very first function, because again, the first time we called this, that function was still running. It was waiting for the second function call to resolve. And that second function call was waiting for the third all the way down until we finally hit that first return. Again, when we hit this condition of having no values left, and then they all returned up. So this is really recursion. Again, we're able to iterate through this list, continually calling the recursive iterator over and over again until we hit its base case. Now, this is not an ideal use for recursion. This is just, you can do it, and I think this kind of shows how it works. Let's tackle one more problem in this video, and this is going to be a very classic thing to use recursion on, and it is something called Fibonacci. If you don't know what a Fibonacci sequence of numbers is, you probably need to go out and watch the Da Vinci Code, but I will explain it. So what we do is we always start with 0. 0 is the first value, and how you would pick or figure out a Fibonacci number is it is the product of its two previous numbers. So we see this sequence here, and 0 plus 1 equals 1. Cool. 1 plus 1 equals 2. 1 plus 2 equals 3. 3 plus 2 equals 5. And that's how we keep figuring out this list of Fibonacci numbers that can go on forever, and it grows really big as we keep going. Now, why this is a great thing for recursion is, let's say we wanted to know the next value. I believe we have 10 here. So we want to know what the 11th Fibonacci sequence is. Well, the only way you can know that is if you know what the 10th and the 9th are, because those are what have to be added together to get that next number. And hey, we might not know what these are, but we can use recursion to keep looking back until we hit this 0, and then we can calculate what the two previous numbers are to be able to calculate a next one. So this is a great case to use recursion. So let's go ahead and just code it out together. We're going to call it Fibonacci FIB. And sometimes the most difficult thing here is remembering how to spell Fibonacci. This just needs to take in a value. So again, we can call it num, we could call it n. It's whatever Fibonacci number we want to know. Now with Fibonacci, there are a couple things on just, again, how you interpret. You cannot have a negative Fibonacci number. Most of the time, you really don't care about the 0th Fibonacci because that is just 0. So what we're going to do is we're going to set up actually two base cases, and this is totally something you can do. We're going to say if n is less than or equal to 0, we're just going to return 0 for this value. Sometimes people will do this, or I'm sorry, num. Sometimes people will put something in, like if it's a negative value, you throw a value error. That's totally all right too. But ultimately, we just, anything 0 or less, we're going to want to say, hey, it's 0, because again, we can't do negative numbers when we're calculating Fibonacci. Now, the other scenario we have is if our num equals 1, and in that scenario, we need to return 1. Again, if this n equals 1, meaning we want the very first Fibonacci number? Well, it's 1 because technically we don't have two numbers behind it in order to calculate it. Once we start getting to that second number and further on, then we actually have enough values behind us to go ahead and calculate the number. So if the number's not 0 or not 1, basically 2 on to don't do infinity because that will take way too long and your computer will run out of memory. But any value after that are actually going to need to calculate it out. So that's going to be our else case. And again, this kind of if else works because again, as long as there's a choice to pick a base case and these two values we've set are our base case, or we still need our recursive case. So if it's not the 0 or the first, it's the second, third, or fourth, what do we need to know to calculate that Fibonacci number? We need to know, basically, let's say if we're calculating 5, which just happens to be the fifth one, well, we need the fourth and the third to calculate 5. And again, if we need the fourth and the third, if we don't know those, we're going to need the third and the second to calculate the fourth, and we're going to need the second and the first to calculate the third. So this is kind of how the recursion works, is we have to keep looking back until we hit a base case, which we just defined. So what we need to do is return, and here we're going to call it twice. We're going to call Fibonacci recursive. This needs to be with n, or our num, minus 1, because again, we have to eventually get down to our base cases. And then we would want to add, calling Fibonacci recursive again, with our num minus 2. And now, basically, any number we give to this, it's going to say, hey, is it 0? No, well then, if it is 0, I'm going to return 0. If not, I go to my other choices. And if the number's not 1 either, it means we're going to recursively start calculating it. Cool. Let's go ahead and test this out. Now we will want to print, because again, we didn't put any prints in here. So we're going to print the return value of Fibonacci recursive being called. Let's start with the fifth one, because as I said, that should end up being the number 5 for us. Let's take this out. Let's go ahead and give it a save. And let's see what we got. It calculated 5. Let's keep testing it. What about 6? Again, we have a few of them here, so we can test out each one of these values. Oops, I don't think I saved it there. And we got 8. Let's keep going. We'll do 7. Seems to be working pretty good. Again, we got 13 as well. Let's calculate our 10th one. 55, so seems to be working. Let's try to go out a little further because we'll also kind of see how big these values start getting. So the 25th Fibonacci, 75,025, pretty decent number. That had to do a lot of recursive calls to go all the way back to 0, but again, worked pretty quickly. Let's try 35 because at some point we're going to see it actually lag and take time. Here we go. So that took a little bit of time. And look, that was 9 million. I'm going to do maybe a couple higher because, again, you do not want your computer to run out of memory. This one took a little bit longer here, we see, and that is 24 million. So, hey, really cool use case for recursion here to calculate whatever Fibonacci number we want. So a couple other things that we might use recursion for in the future. Recursion is used in something called merge sort, which is one of the most performant sorts. So again, that's a great case for it. We use it for graph traversals or tree traversals when we're talking about some more data structure logic, and maybe traversing something like a decision tree is best done with recursion, and that might be something we do in a game in the future. Hope you enjoyed this video on recursion. Again, if you didn't get the first time, play it a couple times over and maybe we'll call itself and you'll figure out what recursion is.